Okay, so as a reminder, hands should be empty at this time. Just like for a bit, I want to try to teach you something new, and I think it's easiest for that to really settle in if you just concentrate and listen to me, and there's no pressure to try to take notes while you go. Notes are good for later. They're nice after you understand something to write down an example so you can look at it later, especially today. Today's going to be a good day to have some nice notes. But while you're figuring everything out, I want you to just stay with me for a bit. So I want to look real quick. I'm going to transition in by using the question we started with and what should we be forgetting. So we've learned how to find all of the solutions to something like this. There's two ways I represented it here for you before. I kind of said it could be 20 or 21 or 22 and so on like that. Anything above 20, including 20. I also kind of wrote a sentence or a part of a sentence. I also kind of said F can be 20 or anything greater than 20. Some wording kind of like that. So that's, if you'll notice, two different ways we could answer that question. What are all the numbers? One is we could sort of list them or show how to list them. And then another way we could show it is like in a sentence or a part of a sentence or a phrase like that. So what I want to teach you today, once we know the answer to a variable inequality like this, there's actually 4 ways we can show the answer. And I want to make sure you're comfortable showing them all 4 ways and understanding them all 4 ways when you see them. So I'm going to switch over to what would have been our thinking task today if I was there and we could have a nice normal think. And I put some inequalities, and I was going to have you just try to figure this out on your own by showing you them. So there are the 4. Some of them I was going to give you the number line way of showing it, which we'll get to. Some of them I was going to give you the words way. Some of them I was going to give you the inequality statement way. And some of them I was going to give you the solution set notation. And have you see if by me giving you the answer one way, you could figure out how to do all 4 of them. Great thinking task. And I'm sorry I'm gone and it won't work out. But this is fine. This is a great one for me to just kind of show you how to do too. So I will. So let's start with this one here. The number line one's already done. I'll come back to that in a minute. I'll talk about that in a minute. But let's talk about the ones we would be the most familiar with already and how it would work. So when I look at this, k minus 4 is less than 3. I want to know all possible solutions here. All possible. Right? There are lots of them. So what I like to know first is what's the number that's going to give me exactly 3. That's not going to be a solution because if I make this side equal to 3, 3 is not less than 3. But it's still a helpful number for me to have, even though it's not going to be a solution. So here I can kind of use the duh strategy and just be like, well, if I did 7 minus 4 is 3, that's going to be the one that makes it equal to 3. I could also, of course, find that by doing the inverse operation. If I want to know what makes it equal 3, just treat it like an equation, and I would say, inverse operation, I would add 4, and that's where I would get that 7. So the magic number is 7 that makes them equal, but 7's not a possibility here. However, anything less than 7 will be. 6 is fine. 5 is fine. 4 is fine. Even if I went down to something like 3, I would get a negative number, still less than 3. All good. So really the way I like to show this is in my solution. I'm going to start with this solution set one. And it's really like, 6 is okay. 5 is okay. 4 is okay. And so on. But there's actually some more numbers that I need to make sure I get. So one is there's the numbers that are not whole numbers that are there. The numbers like between 5 and 6, like 5.5, still okay. Or like 4 1/4, still okay. So I like to put in parentheses down here and all fractions and decimals in between. I can't possibly write all those numbers, but I can note that I know that they're there. So it's not just 6, 5, and 4, but it's also the numbers in between those that are decimals. Now, there's also some numbers more than 6 that work, like 6.5, 6 3/4, 6 9/10. It's really like I like to put, I can go all the way up to 7, but not 7. So I like to put it, but exit out, because I can't do exactly 7 or it won't work. But then I can kind of say 7, 6, 5, 4, and so on, and all the fractions and decimals in between, and kind of like Xing out the 7 is my way of showing I know it's almost 7, and even like 6.999999999, but not 7. And then the last thing I do, fancy math language, you don't really have to do this, but in math, we would put a solution, it's called a solution set. We would put it in braces, they're called like that. They're kind of like parentheses with like a point out of them. And so that's one way to show all the numbers that k could be. K could be anything here. That's one way. A very similar way we do that is with a number line. So this number line is already done. And you'll notice, just like I kind of did in that example before, we want to start shading in the numbers that work on the number line. So like 6 worked, 5, 4, 3, all the same numbers we have here, except it's also the numbers between them work too. So what we do is we end up like shading the whole number line, like we're putting an infinite number of dots all over this thing. Any number less than 6 is okay. So are the numbers above 6 all the way up to 7. So the same thing here, we don't want to go 7, but we do want to do 6.5, 6 3/4, 6.9, 6.99, 6.99999. It's like everything up to 7, but we circle it to show that it's not shaded. It's like everything right up to 7, but not 7, and I circle it to show that I, on purpose, have not shaded it. It's kind of like putting the X through the 7 here. So it's kind of like just putting that X on the 7 here. It's like right up to 7, but not 7. Right up to 7, but not 7. Okay, that's two ways we do it. They're very similar. Another way we can do it is with what we call an inequality statement. So what I want to say here is, you'll notice this shows me k can be all the numbers less than 7, but not 7. This shows me k can be all the numbers less than 7, but not 7. The way we show that with a simple inequality statement is this. We just say k can be any number less than 7, but not 7. I'm not going to put the little equal sign there because it can't be 7. So this literally just says k itself, for this to be true, k can be any number less than 7. We call that an inequality statement. The last way I can do it is in words. I've been using a bunch of words when I show you these, and the last one is you can just write a sentence that literally says that. K can be any number less than 7, but not 7. And I like to make that perfectly clear here too. So all these show the same thing. K can be any number less than 7, any number less than 7, any number less than 7, but not 7, but not 7, but not 7, but not 7. That's how we do it. So that's just 4 ways to kind of show the answer all to the same one. Let me show you a second example that is pretty similar but a little different. This one's going to have a less than or equal sign in it, and it does change the deal just a little bit. So when I start to look at that, now I really do want to know what's going to make these equal, because the number that makes them equal is going to be part of the solution. So let's figure that out. So I might be able to just duh this one. 9 minus 6, that's going to give me 3. I can just spot it. If I wasn't able to duh it, I could just say that subtract 6. So I'll find what makes them equal by doing the inverse operation, which of course is 9 as well. So really what I know here is, I like to start with my solution set. You don't really have to. It's a good spot for me. So 9 is the number that's going to make those equal. So I'm going to start there. 9 makes them equal, and in this case I can include the 9 because of the equal sign. I'm not going to need to exit out like last time. because 9 actually is a solution here and is okay. So now anything less will be fine as well. So if I do 8, that's less. If I do 7, that's less. If I do 6, that's less, and so on. So here, and it's 9 and everything less, and all the fractions and decimals in between. I can't write all those fractions and decimals. There's an infinite number of them, but I can show my reader that I know what I'm talking about. We put that in these things called braces. That's not really that important if you don't, but you know, I'll show you the fancy math. So in this case, the numbers that will make this inequality true are 9, 8, 7, 6, and anything lower. So you'll see in the number line version of the solution, that's what I've shaded. All the numbers less than 9 start to be shaded. 9, 8, 7, 6, 5. It's like I'm putting dots everywhere on the number line here. Now, on the last one, we even wanted to show the numbers above 8 are fine. 8.5, 8 3/4, 8 9/10, 8.99999. The last one, we circled 9 to show that we're not shading it. This one, we do want to shade it because 9's a solution. So what we do is we put a big dot on the 9 to show that we're making very clear we are shading the 9. So if the 9 was not a possibility, we would circle it to show that we're not shading it. Since it is a solution, we want to put a shaded in circle on it so that we know that we are shading it. Cool. Let's go to the inequality statement. So you'll notice down here, I've shaded all the numbers less than 9, including 9. All the numbers less than 9, including 9. So J can be any number less than 9, including 9. We're going to put the equal sign there to show it can equal 9. That's fine. Or it can be less than 9. So the inequality statement is just showing what numbers can J be to make it true. And J can be any number less than 9 or equal to 9. Last thing is words, and I just write what I've been saying. J can be any number less than 9, including 9 in this case. 9 is okay. And that's how you do it. So that's the 4 ways you can represent an answer. I like you to understand them all, though there will probably be ones that you favor more than others. So we're going to head to your notes example next. So I appreciate you just listening and thinking with me for 12 minutes to get the hang of this. Now I do want to write an example or two down in your notes so that you have a really nice one to look back at if you forget, because there is quite a bit to this. You can open your binder now, and in the next section of the lesson, we'll take a few notes.